Hello, my name is Mr. Chu, and you are welcome to my channel, Mr. Chu Study Room. Today, our study is about rigid motion. In a rigid motion, we are going to rotation. Rotation of a point through an angle about the origin. Rotation of a point through an angle about the origin. What is rotation? Rotation is just a turning about a fixed point. So rotation is turning about a fixed point. That means you don't change the position where you are standing if you are rotating. You just stand at one place. You can, so like standing at an assembly ground, you turn to your left, you turn to your right, you turn facing your back. These are all processes of rotation. Like keeping your arm and then turning your arm about this way. That's all rotation. Opening a door. That is all example of a rotation. All right. And rotation for calculation purposes, rotation is generally in anti-clockwise direction. So rotation is generally down. Yeah, rotation is generally done in anti-clockwise direction, meaning that it moves in the opposite direction of the movement of the hands of a clock. All right. And what is today's lesson about? It's just how to get the rotation formula. Since it is something students have to remember, most of them forget. So I am just here today to find another easier way of remembering rotation formula in an anti-clockwise direction about the origin. All right, what is it about? You just draw your angles, if you just same as 360, then you have your 90 degrees, 180 degrees, then 270 degrees. Remember, these are all in anti-clockwise direction. Anti-clockwise direction. All right. So this is how to remember the rotation formula. You write your points, the coordinate of your point x and y here, and then you assume a man riding bicycle, climbing and descending a hill. So the general assumption is that when you are riding a bicycle, you are climbing a hill, energy is lost. And when you are descending a hill, energy is retained or maintained. You don't lose energy, you don't gain energy. You just sit and the bicycle descend the hill. So we are going to use this, and x, whichever coordinate is down, will climb to the top, which means it will lose energy. And whenever energy is lost, you negate the coordinate that is losing the energy. And whenever it is descending, energy is maintained. So you maintain it or you retain it without changing the sign. So that is how we are going to go. So a man riding a bicycle in a hilly area, he climbs and descends. So the first one is a rotation of 90 degrees anti-clockwise about the origin. So here, this y here, it will climb to the top. And here, energy is lost. Because energy is lost, it becomes negative y. And this x also descends downwards. Energy is retained or maintained, no energy is lost. So you get negative yx. This means that if the point xy is rotated in 90 degrees anti-clockwise direction, the formula we are going to get will be, so that is xy, rotation of 90. The formula is going to be negative y x. So that is it. Example, let's say we have 2, 5. The point 2, 5 rotated in 90 degrees anti-clockwise direction is going to give us negative 5, 2. That is 90 degrees anti-clockwise rotation. Then what if the question asks you to rotate in 180 degrees? Remember 180, whether you turn clockwise or anti-clockwise, it is still 180. So here now it is a turn of the x to climb. When it climbs, energy is lost, so it becomes negative x. Negative y descend, no energy is lost, energy is just retained. Energy is not gained, energy is not lost, so it still remain negative y. All right, so this means that a rotation of 180 degrees is negative, a rotation of the point xy in 180 degrees direction gives us negative x, negative y. So that means when x and y rotate in 180 degrees, we get negative x, negative y. So with the same example again, let's say 2, 5 through 180 degrees will give us negative 2, negative 5. All right. Then the last one, which is rotation of 270 degrees anti-clockwise about the origin. Now y is climbing, so energy will be lost. So when we negate negative y, we get positive y. And then this one comes down, the negative x comes down, descending, energy is retained, so we still have negative x. This means that when the point xy is rotated in an angle of 270 degrees anti-clockwise, the formula will give us y, or the image will get to be y negative x. And with the example again, 2, 5 through 270 degrees anti-clockwise gives us 5, negative 2. So remember, I am not writing the direction because I already said at the beginning of this lesson that generally rotation is done in anti-clockwise direction unless the question says it should be in a clockwise direction. So as you can see, if we should continue this trend, the next 90 degrees will give us 360, which will be the same as the 0 degrees. This one moves and becomes positive x. This one moves down, becomes y still. And you see that that will be the same as the 0 degrees that we have here, which brings us back to the original position. All right. Then what about if the question asks you that you should do the rotation in a clockwise direction? So I just want to demonstrate how rotation is done in another way quickly. A rotation using a diagram quickly. Let's say you are standing directly facing here. You are facing here. Here is your 0 degrees. 90 degrees anti-clockwise. That means you'll be facing here 90 degrees anti-clockwise. And then 180 you'll be facing here, 270 you'll be facing here, and then 360 you are back to the original position. All right. So the relationship between anti-clockwise and then clockwise rotation is that as you move here from here 0 degrees here to this which is 90 degrees anti-clockwise, if you are facing the same 0 degrees here and you are to move to come and face here, but this time you are using the clockwise direction, you see that you move here 90, come here 180, and then 10 270 before you be facing the same direction. This means that 90 degrees anti-clockwise is the same as 270 degrees clockwise. So that means if you are given a point and you are to find the image through an angle of 270 degrees clockwise direction about the origin, the formula will be the same as the 90 degrees anti-clockwise. And then we can try that. Remember when we're doing the 180, I said that 180, it doesn't matter which direction. So you see that as you are facing here 0, anti-clockwise, here is 90, here is 180. Let's face the same direction and 10 clockwise. This will be 90, this will be 180. You see that both of them are facing the same direction. So that is why 180 doesn't matter. But let's go to 270. So you see that I'm facing here 0 degrees. 270 anti-clockwise, I'll move here 90, 180, 270 here. I'm facing the same direction. Now I want to turn in a clockwise direction. You see that I moved 90, I'm facing the same direction already. Meaning, from the same position, a turning of 270 degrees anti-clockwise will be the same as 90 degrees clockwise. So 270 degrees anti-clockwise is equal to 90 degrees clockwise. So this is how you can quickly remember the rotation formula in case you go to the exam hall and you forget the formula. You just quickly assume a man riding a bicycle in a hilly area with your point X and Y being 0 degrees. Then when the man climbs, energy is lost, so you negate the Y. When X descend, energy is retained, so you maintain it. When X climb again, energy is lost, so you negate it. This is negative Y descend, energy is maintained, so you keep it. And until for whichever you are looking for. And most importantly, don't forget that this formula is only for anti-clockwise rotation. And the good news is that when they ask you for 90 clockwise, you just come and pick the 270 anti-clockwise for your 90, and I've demonstrated that with this diagram. And then when they ask you for 270 clockwise, it's the same as 90 clockwise. So that is where I would like to end my lesson for today. I hope you have enjoyed it. Very short and simple way to remember rotation formula, especially in an examination hall. I hope this lesson has been of help for you or to you. If yes, please subscribe to my channel, Mr. Chu's Study Room, for more videos. Thank you and hope to see you again. Bye bye.